Hi guys, welcome. Today is day 15 and we are looking at lesson 57. So nearing the end of this unit. And today we're looking at just this lesson and it's operations with small numbers and scientific notation. So if we're using scientific notation to write really large numbers, we can do the same thing to write really small numbers. Okay? Remember our rules of it's always base 10, but it applies for any exponents with the same base. We're multiplying, we add the exponents. We're dividing, we subtract. Okay, that same rule we've gone over and over and over. Now we can have situations where we're multiplying two numbers in scientific notation, like 1 times 10 to the power of negative 2 times 2.5 is 10 to the power of 3. Okay, so in this situation, since we can multiply in any order, okay, I'm going to multiply my coefficients first. 1 times 2.5 is 2.5. Then 10 to the power of negative 2 times 10 to the power of negative 3. Well, I add the exponents since I'm multiplying, so negative 2 plus 3 is positive 1. So 2.5 times 10 to the power of 1. So just like you would multiply any other expression, same thing. We got to make sure that we end up with a coefficient that is greater than 1 and less than 10. So it still needs to be in scientific notation, although this would just be, this would work out to be 25. So I'd probably write as 25, not 2.5 times 10 to the power of 1. But if you see one on a test or a review and it's division or multiplication in scientific notation, we need to keep it in scientific notation. Okay, so let's look at one of these examples here. 4 times 10. So 4 times 10 to the power of negative 6. Oh, we're multiplying this one. Times 5 to the All right, so again, coefficients first. 4 times 5 is 20. 10 to the power of negative 6 times 10 to the power of negative 4. Okay, I'm, in this case, same base as always. I'm multiplying, so I add negative 10 plus negative 4 gives me negative 10. Okay, now this is where it gets not a little tricky, but this looks like scientific notation, but really I need this to be 2.0. So I need to divide by 10 to make this 2, or 2.0. If I divide this by 10, I need to multiply this by 10 or add 1 to this exponent. And negative 10 plus 1 is negative 9. So that's the one thing there. If your coefficient ends up being less than 1 or greater than 10, just move the decimal, but don't just move the decimal without adjusting this accordingly. So 20 can be written as 2 times 10 to the power of 1, which means 10 to the power of negative 10 times 10 to the power of 1 gives me 10 to the power of negative 9. Or you can just think I move the decimal, I have to add 1 to the exponent here. Then if I'm dividing, so let's say example D, I get 4 divided by 4 times 10 to the power over 5 times 10 to the power of, what was it? Negative 2. Okay. 4 divided by 5 gives me 4/5, or 0.8. Okay, 10 to the power of negative 8 divided by 10 to the power of negative 2, I subtract. So negative 8 minus negative 2 gives me negative 8 plus 2, which is negative 6. Okay, I have to multiply this by 10, which means I need to divide this by 10. Okay, so this would be 8 times 10 to the power of negative 1, so I have to take 1 away from here. If I'm multiplying by 10, I'm dividing by 10 to keep it equivalent. So 8 now times 10, take 1 away, it now is negative 7. So when you get to the end, you may have situations where you have one last step with your coefficient just to make sure that it's in scientific notation. So don't just get here, you're so close, but don't stop there. Make sure it's in the correct form so you get full credit on the test or review or whatever it is. But yeah, it's just the difference of a decimal place, but it will obviously affect whether it's right or wrong. Okay, we'll look over maybe not all of them, but we'll look over these. You'll see some of these on the test and review, so we'll make sure you guys are squared away and good to go with those. All right, that was the only lesson for today, so I'll see you guys in class.